right, hello everyone. Welcome to our talk, Project Pigeon, using agentic systems to revolutionize static analysis. My name is David Bohannon. I'm a principal engineer at Black Duck, and I've been with the company for about a decade. So I started on the services side, doing penetration testing, code review for various clients, and then moved over to the product side, where I've worked on both dynamic and static analysis tools across our portfolio. And over the past several years, my focus has been on applied AI solutions. And with me, I've got Chris Fearon, who'll be co-presenting.
Yep, thank you very much. Firstly, thanks for hanging on, guys. I know it's late in the day and late in the conference, so it's really great to see a turnout. So we're chuffed about that, and we really want this to be engaging and also interactive. So if you have any questions, please just throw your hand up at any point. So seriously, I'm Chris Fearon. Again, I've been with Black Duck for about 10 years now as well. We have some of our colleagues here, and we've all worked closely over those years. And Vanita actually presented in the room adjacent to us. But I've been working in open source software and security in open source software for 10 to 15 years. Very much focused on security research, and then moving into the product side where we work together on innovative solutions and understand the next technology trends in the products that we offer. And of course, we've been working together lately on what we term Project Pigeon. And of course, like everybody, we're exploring AI and how it can actually be used and augment our existing solutions, right? Not necessarily replace, but we're looking at how can we augment.
And when Chris says we've been working together closely, we've in fact been working together so closely that most of the company now thinks I'm Irish. And they're like, how's the weather in Belfast? Like, I'm from Atlanta, I don't know. So yeah, very, very much a lot of collaboration between the two of us over the past 6 or 7 months.
Yeah, absolutely. So a couple of things that we want to cover today. We want to start and do a bit of a primer on the traditional hurdles of SaaS and what we've seen. Obviously, we're from Black Duck. We're predominantly known for SEA and SaaS, but we want to explore some of those hurdles, the traditional hurdles, from our perspective. And then we're going to dive a wee bit into Project Pigeon itself, right? How are we leveraging AI in the world of SaaS, right? And some of our observations, the positives, the negatives, and where we think the technology could go. And as I say, they're pushing the technology beyond just static analysis, right? We think there's a lot of benefits to LLMs and AI in general, but part of this journey is exploring how we can augment traditional SaaS. And as I mentioned, we'll sort of wrap it up with challenges and limitations that we have seen during our research and our experimentation. And some of the challenges and limitations, there are various approaches that we still need to explore. This is absolutely not a finished article. We are continuing to research and work through that. So, a lot of people are wondering why Project Pigeon. So David, take us away.
Yeah, so Project Pigeon is the internal name that we've designated for the work that we're doing using AI technologies to find vulnerabilities in code. And one of the questions I get, especially internally, right, is people are like, dude, why Pigeon? Why not like Super Security Falcon or something really cool like that? And so there's a bit of history here. So the US military actually had a Project Pigeon back during World War II. And who is familiar with the US military's Project Pigeon? Has anyone ever heard of it before? Yeah, not likely. So what Project Pigeon was, essentially the US military took pigeons and trained them to peck at targets on a radar screen. And when those pigeons were properly trained to peck at those targets, they would take the pigeon, take the radar screen, shove it into the nose of a bomb, and then drop it and let the pigeon guide it to the target by pecking at the radar screen. Apparently this actually worked fairly well. I wouldn't have thought so, but apparently it did. And what they realized, though, is that these pigeons, even though they were pretty good at guiding these bombs to their targets, they were non-deterministic. So the pigeon would randomly peck at some other spot on the screen and cause it to veer off, or it would just get distracted and just stop pecking altogether. And so what they ended up doing was saying, well, heck, let's just take 3 pigeons, each with their own radar screen. We'll all shove these into the nose of the bomb. Then we'll let all 3 of them steer it. And if 2 of the 3 pigeons say, hey, it should go this direction, then that's the direction it would go. And so we at Black Duck don't advocate launching pigeons and bombs, but what we quickly realized is that this approach of like taking 3 pigeons and using the answer from 2 of them if they were both in agreement is essentially the same thing we do with with AI technologies with the jury approach. And we quickly realized there's a lot of other similarities between pigeons and AI technologies like LLMs. They're useful for specific tasks, but they're difficult to keep focused, and you get non-deterministic results. And so that's why we named this thing Pigeon, and being from Black Duck, the bird theme sort of seemed to stick, right?
Yeah, and of course we've seen through various talks at this conference where a lot of the material sort of led up to these 3 bullet points, right? It's how you apply the LLMs in your work stream, right?
Yep.
And in your tooling. You can't just expect to use these tools and it will just fix everything and magically be the magic bullet, right? So it's been really good to see that some of the content has really addressed some of that and highlighted it at least. So when we go into the traditional hurdles, with static analysis, you can see here, parsing the languages, right? So just the languages, the frameworks into their syntax trees, generating the call graph for which we can then define the features. And then we have to actually write the checkers for those features and for those security detections, right? And that is time consuming, right? That requires a lot of expertise, a lot of skills, and a lot of time. And of course, software is growing, right? From the SCA perspective, we produce reports of just the amount of OSS that's being released and consumed. But when we're in the world of SaaS, we have to do that work and that research work, and it's very difficult. And you can see here, writing the rules for those call sites and the data flow, that is really intensive, right? And that's a specialized skill set. Not everybody can do that. And it's, often it's difficult, it's challenging, and not everybody wants to do it, right? And I look at David here because you've spent time in this world, right?
I have, yeah. Yeah, I mean, we're talking, just in our organization, hundreds of thousands of man hours a year that goes into this. And so I want to sort of use this graphic here to explain why this is such a hurdle for traditional static analysis. So if I set out to build a static analysis tool, the first thing I want to do is say, all right, well, what languages do I want to support? So I'm going to use something like the Stack Overflow survey and say, like, well, all right, which ones are most popular? And somewhere at the top, I'll pick one of these and say, all right, Python. I'm going to start with Python. And so the first thing I have to do is get a parser to parse that language into those ASTs and call graphs and that intermediate representation that our traditional static analysis tool needs to be able to navigate that code. Well, if I look at Python, there are multiple supported versions of that language with their own language features. So Python 3.14 might have something that's not existent in 3.13 or 3.12. And so I've got to figure out which of those I want to support, which of those language features I'm going to focus on. And then within that Python language version, I've got to go through and model all of the core features within that language. So identifying sources, sinks, pass-throughs, so that, again, our engine can navigate that core code in that language. Then we've got to write rules. So what is it actually trying to detect? But as developers, we don't just use the core language, right? We use frameworks and other third-party libraries and plugins. So again, with Python, there's easily more than a dozen, we'll call them mainstream frameworks that I've got to decide, all right, which of these am I going to support? And then for each of those, I have to go in and identify all the different language features, the modeling of sources, sinks, and pass-throughs, writing rules. And then, in addition to that, there's this whole ecosystem of third-party libraries and packages that I've got to go and figure out, all right, which of these am I going to support? So for example, in just the PyPy ecosystem, as of a few weeks ago, there's over 600,000 Python packages. So obviously, I'm not going to support all those. I'm going to try to determine what are the most popular ones and write rules for those and do the data flow modeling for those. And so as you see, the problem here is if I'm a user of this tool and I'm using Perl or R or some less popular language, or I'm using Python but a different version than what's officially supported, or I'm using one of these packages that is less popular and there aren't explicit rules and data flow models for those, there's going to be significant gaps in the coverage when this tool scans my code. And the problem is then we're missing stuff, right? We're getting false negatives. And to sort of demonstrate this, on the left, we've got a code snippet. I believe this is a Flask a fast API login endpoint. So we see that some data is coming in from the request. It's being concatenated into this SQL string. Basically, your classic SQL injection, right? And when we break this down into the intermediate representation, which is our ASTs that we see here, this is what this looks like. And so one of the things we have to do is for each of these functions and methods within this particular framework, we've got to model those and tell the tool, hey, look, if you see request.form, that's a source of untrusted data, right? Data's coming from the user. It needs to be marked as untrusted. If we don't do that, then what happens is when the engine is navigating the code, it sees, oh, there's some data that's being concatenated to this SQL string, but I've never been told that it's untrusted, so looks okay to me, and we miss this defect. The other scenario here is that there's a language feature that's not supported, which causes a break in that data flow trace. So again, here in the SQL string, we see that it's being built using the Python f-string variable interpolation. So if the particular parser that we're using doesn't understand that variable interpolation, then what happens is our graph ends up looking like that. And we end up missing the fact that, hey, there's some data that's being concatenated to this string here. And so again, we have false negatives.
Yeah, so I think it's fair to say it's difficult, right? It's time consuming and it's a real specific skill set. And you know, some of the additional limitations, right? With the SAS, it's very much binary result. You know, it's 1 or 0. Either you have it or you don't. You find the issue, you don't. You have the rule for it. So understanding that context of the code and detecting logic issues or business logic issues has just traditionally been very difficult for SAS. And it always will be, right? Yeah. I don't think we'll ever be able to resolve that. And bad coding patterns, right? We're having to write these rules against these ASTs and these graphs, and we couldn't possibly do everything, right? So it's going to be very difficult to detect those.
Yeah, like as developers, there's like an unlimited number of ways we can screw stuff up, right? An unlimited number of ways we can write bad code, whether it's, again, using various language features, logic, or pulling in some package that no one's ever seen before that the tool doesn't support.
Yeah, so that kind of is just a real accelerated primer on some of the traditional hurdles. So what about Project Pigeon, right? So new approach to securing code. So we've seen a lot of commentary about how we actually use LLMs in our ecosystems and our tooling and our pipelines. And it's very important, especially in this discipline, in this domain, using the agentic-AI approach to really break the problem down into real small, contained units of work, essentially, right? And we'll have guardrails that actually validate those work and the outputs, the inputs and the outputs. So, you know, yes, we are using LLMs and AI is in the title, right? But the reality is the framework that goes around it is probably more, more challenging and difficult to set up than the actual implementation of an LLM, right?
Well, yeah, because they're like pigeons, right? So we got to do all this work to keep them focused and on task and break the problem down in something small enough where they can actually be successful.
Yeah, and you know we've listed it here in the third point down, but this is arguably one of the biggest advantages of using LLMs in this process. It's language agnostic out of the box. Right? Now, obviously, the LLMs, you're going to have LLMs that are trained on specific languages. Over time, you'll have, more obscure languages are covered with, pre-trained models specifically. But generally, as the models are getting bigger, right, we're trying to get to multi-use models. They're language agnostic, right? And that is a huge benefit. It's number 3 in this list, but it's one of the primary benefits. With our solution, we've no rules. We've no ASTs to build, we've no graphs. And the other item here is the build this cross-file data flow, right? That's always been a challenge with static analysis. And if you're missing parts of that graph that David was showing, then you just miss that entire chain, right? And you miss the context. So we don't have to build those graphs. We can use the reasoning of the models to help us with the data flow analysis. And you should be able to tie those items together that we're talking about, where the discrete units of work and leveraging the reasoning for those specific units of work to do data flow. That's where there's real benefits in harnessing the LLMs here. And that human-like reasoning, right? So we come back to the types of items that we're finding, right? We mentioned that the business logic issues are hard, those configuration type issues that are really traditionally hard for SAST. LLMs are really good at this, right? And malicious code detection. These are type of issues that we see the LLMs bringing real value into the world of SAST.
Yeah, and so one of the approaches that we took is, like he said, there's no ASTs or call graphs. So we're actually operating on the source code text, even as we're doing that data flow tracing. So what it allows us to do is really have this almost human-like approach to static analysis. The same way that I would look at code and navigate it as a human reviewer, we've actually modeled the system to behave very similarly.
Yeah, and what we've observed is this very much operates like a human pen tester over your shoulder or a human code reviewer, continuously monitoring your work and what you're doing and highlighting those issues. So, the traditional SAST where you would run this periodically every check-in, that may not be the position for a technology like this, nor should it be, nor should we try to shoehorn this into traditional flows. It's understanding those limitations, but also where is it really good and how can it augment what we do. All right, go ahead.
Yeah, so like Chris said, this is more than just a prompt or an agent pointed at a code base. And to get to where we're at, there were a lot of dead ends that we went down. For example, one of those was early on we said, well, heck, let's just create a supervisor that has multiple agents, and we'll just point it at the code and say, hey, go find me the vulnerabilities, right? And the problem is that it would analyze 4, 5, 6 files out of the 100 in the code base that we gave it, and say, look, I found 4 things for you. And we're like, well, that's good, but you only analyzed a few of these things. Like, you're supposed to analyze the whole thing. It was like giving a 5-year-old a task, and they come back 5 minutes later and they're like, oh, I'm done. It's like, no, you're not. And so we got more authoritative. We said, no, you've got to analyze all these files. And it would come back and say, I did. And we look at the logs and we're like, no, you didn't, you're a liar, right? So we quickly realized, again, like pigeons, we got to break this thing down into small tasks and use the LLMs where they're needed, but then also have that sort of programmatic approach of multiple stages within the system that we're in control of.
Yeah, and it's very tempting, and we've all been there where we're like, we can get more delivered quicker, right? And there's a temptation just to say, let it rip and go for it, and we'll just trust what it says. And we've seen that through this conference, right? Yep. The talks have been saying about we spend more time debugging, right? So we turned that around and we spent more time in sort of building the guardrails and breaking those units of work down and validating what's going in, what's coming out at every step, right?
Yeah. All right, so at this point in this talk, normally people are like, hey, that sounds really cool. Is this like something you guys designed on the back of a cocktail napkin? Like, is it vaporware? Like, what is this thing? How far along is it? It's very much a real system. In fact, we've been using it to find multiple 0 days in real-world open source applications. So here's an example of a password memory leak in the password4j library. We analyzed it with Pigeon. It found this vulnerability. We worked with the maintainers to submit a pull request and get it fixed. And we've got another example here where it found a denial of service vulnerability caused by a divide by 0 condition in the Rust vproxy server that allowed an unauthenticated user to crash the whole system. So again, we worked with the maintainers, said, hey, look, we found this thing. They issued us a fix. The CVE was issued. And we help them make their code a little more secure. And those are just 2 examples that we can talk about. There's actually a handful of others that we can't quite disclose yet because we're still working with the maintainers to fix those and get those CVEs issued. But I want to point a few of these out. So one is a Java application with over 10 million downloads where we found DOM-based XSS. Another is a Java library with over 120,000 dependent projects with recursive block denial of service. A Rust server with 26,000 downloads with broken authentication. A Scala application with over 6,000 downloads with a zip slip vulnerability. And what I want to highlight here is that this isn't like Bob's homework project that we're scanning on GitHub and saying, oh, there's a vulnerability here. These are real applications that have strong enterprise or community support behind them. These guys are doing static analysis, and they're missing stuff, and we're finding it. So we're really excited about that.
Yeah, and just on that point, right, it's not as if we had to do 100 hours of triage to find that one issue in a report of 3,000, right? Part of this process, and we'll get into some of the details later, but as part of those guardrails that were mentioned with the discrete tasks, there's oversight at every level of our interaction with an LLM, and we can really tune out some of those false positives, right?
It's automated oversight, right? We've got essentially agents that are doing oversight and checking the work of the previous agent.
Yeah, absolutely. So we've obviously, the Juliet benchmarks, they've been used for years, and the likes of the OS WebGoat, they are applications that a lot of these scanners are trained on, right? Because that's what customers will do. They'll pick it up and fire it and just evaluate. Now, we're also aware that the LLMs know these libraries, right, and these benchmarks, and we understand that there's probably a bias towards some of this with the models. But what we will say is these results are consistent with what we've anecdotally found, right, when we're scanning our own applications, our own benchmarks. And on the benchmarks themselves, right, you can see that we're getting significantly more true positives for a slightly less false negative as well, right? So it's working in both directions. And of course, because it's language agnostic beyond Java and C here, we're seeing that we're actually consistent across some of our findings, right? And just on the data sets as well, because hopefully somebody will recognize it and ask, but David, we went through and we cleaned the data set, right? So we wanted to remove CWE references or comments of this is a vulnerable code example, right?
Yeah, anything that LLM could use to cheat, we anonymized that and stripped it out. Yeah. So one of the other cool things that we're pretty excited about is the ability for this technology to analyze proprietary languages and libraries. So let's actually back that off real quick. So all right, if we look at this snippet here, who can detect the vulnerability? What's wrong with this? SQL injection? Yeah, so we see that the data is coming in from this HTTP request form as a username and password. It's being concatenated to the SQL string and then executed against the database. So your textbook SQL injection. Who can tell me what language this is? Anybody?
Kind of looks like basic.
Sort of like basic. Yeah. Some people say maybe COBOL or something like that. Well, it's actually a trick question, right? It's not even a real language. It's just pseudocode. All right, just pseudocode. So my question to you is, how in the world were you able to determine this is SQL injection when you've never seen this language before? You've never seen the libraries and method calls that are being invoked here. How do you know it was SQL injection?
I mean, it's a simple query.
Yeah.
That pattern recognized immediately.
Exactly. So you look at this and you say, I've never seen this language before, but I see select star from user, blah, blah, blah. I recognize that as a SQL query. And when I look at, all right, well, where's this username and password coming from? I see, oh, it's coming from a request. So we as humans understand the technologies in use here. We understand that, hey, this is a SQL database, a SQL query string that's being executed against it. I understand HTTP request technologies. And then I understand basic coding languages, right? I understand the concept of like functions and methods and variables and whatnot.
And that's the intent, right? It's the intent that the SaaS tools will struggle with, right?
So I can look at this and just like you did, say, hey, this is a SQL injection vulnerability. Well, the really cool thing is with Project Pigeon and the technology that we're using, it's actually able to do the same thing using that human-like reasoning. So here we say, when we scanned this snippet, it actually found the vulnerability and said the data is untrusted because it originates directly from an HTTP request form parameters, username and password. And it's concatenated into the SQL query without any sanitization. So just like you and I read this as a human, the AI technologies and agents that we're using is actually doing the same thing. And it's saying, I've never seen this language before, but I understand other languages, I understand the technologies, I can fill in the blanks and determine, hey, there's a problem here. So it's really cool.
Yeah, absolutely. And this goes to show where using those discrete units of work and actually applying the LM with the guardrails, right? We can actually start seeing where this is powerful, and we start getting hints as to where this can be really leveraged, right? Yeah. We're not just throwing these prompts and throwing a code at it and saying, where's the vulnerability, right?
Yep. And so we've got customers that have come to us and said, hey, look, I've got this proprietary language that no one else supports. Can you guys support it? And traditionally, our answer has been, look, we've got this long list of other languages that are higher priority right now. Like, it might be a few years, if ever, before it happens. But that's no longer a problem. With this technology, we can be like, yeah, we can analyze it right
Yeah,
now.
and we're not saying that this is the final result and this is what everyone should go and look at, right? What we're saying is this is an indicator to us that where there are proprietary languages or where traditional tools don't have language support, this can actually help you on your journey, right? We're not saying this is the final solution, but we think, given the platform that agentic-AI offers, there's a way in which we can supply additional context, right? We've heard about the vector stores, the RAGs, etc. Where you have proprietary languages where the model has never actually seen the language, yes, it has reasoning, but with that context, it can actually apply some of that knowledge and context to some of the problems we're trying to solve.
So one of the other cool things that we've realized that this technology is really good at is malicious code detection. You want to explain that?
Yeah, sure. So there's a couple of recent supply chain hacks. These should be all familiar to everybody in the room. But one of the observations we had was, you may be able to. It's going to be very hard for traditional SaaS tools to find these issues, right? Because the attackers are obviously using novel new approaches or novel new entry points that aren't typically scanned, right? But what we actually were able to identify, this one was to do with. This was the first AI one, right? This is where we were actually leveraging AI on the user system to exfil data.
So like with malware detection, it's sort of this cat and mouse approach, right? Of the attacker comes up with some new novel way of attacking the system, and then we as defenders have to play catch up and write a rule to detect that approach or that signature or whatever. And so what's significant about this index singularity hack is that this is the first time malware or malicious code has been used to actually probe a system for a coding agent and then prompt that coding agent to do the malicious work on its behalf, right?
Yeah, so when obviously, we didn't find this ahead of time, right? But we wanted to understand where Pigeon was if it hadn't even known about this issue, right? So when this was released and we were able to get access to the code, we just threw it at it, and let's say with our existing process and framework, how good is it without us telling us what it's looking for, right? And of course, you see the line here, right? This shutdown was identified as being suspicious, right? And this particular area of the attack was really about just slowing the attacker down, the defender down, right? The user on their machine, every time there was a bash shell or whatever, they just shut it down, right? And then we've seen this here item, sensitive data exposure, right? Now, typically, you may use that in your code base, right? But we've seen it's flagged this because what was actually happening was the malware was using the organization's repo to host its own data, right? So then the attacker could come in and take it from that repo. And then we have the static code injection, and this is actually something that we were really impressed to see, to be honest. And it kind of surprised us, right? Because we scanned the action files, and we actually found the entry point from the attacker's perspective, right? So they were using some of the PR title and body content to actually inject into the supply chain, right? Or the workflow, the build systems. So we actually were able to get the entry point and also the indicators in the code of what the attackers were doing. So, it's great that we were able to see these individual items, right? But if you didn't know about this attack, you may look at them, maybe pass over them, they're not that important or whatnot. But this is where LLMs now give us an approach to say, how do we combine these, right? How do we use the MITRE ATT&CK framework to say these, individually, somewhat suspicious items together are actually really significant, right? So, it would be very difficult to do that in, vulnerability management today. But because we've got the reasoning in the model that's been able to accurately identify these individual items that are suspicious, collectively, you can see where we're going with this, right? We can actually highlight that behavior.
Yeah, so instead of getting a report of a list of issues, we can actually generate a report that says, hey, look, here are the things that we found, but because you can chain these things together, this is actually a much bigger issue than if these things were found individually.
Yep, and here's just another example. So this was about crypto hijacking on wallets. And by the way, just before I go into this, I think the previous attack, as sophisticated as it was, I think the attackers only got away with like $20 or something. It could have been so much more significant, right? I mean, if it wasn't just quickly going for the crypto, it could have been horrendous. Yep. But with this particular hack, right? This is where we're in JavaScript, we were hacking the APIs on the client side. But what was interesting about this, what we actually observed was in the payload, it was triple base 64 encoded. right? And traditional SaaS would have struggled to capture some of that. And we were actually highlighted, right? It's got obfuscated code. So again, we've got two indicators of compromise here without training the LLM or the system to find this thing, right? Like, yes, we've got, we've iterated our prompts, right? But we've leveraged our knowledge of call graphs and AST and our historical knowledge and sort of applied it to this new AI world, right? And given the SCA and the open source experience that we have, applying all that knowledge to our prompts, but also engineering discipline around the agents and the framework of Pigeon, we can now start surfacing the interesting things, right? Whilst getting rid of the false positives.
Yeah, so normally at this point, folks are starting to wonder, like, all right, what's the catch? This sounds like some cool results, but I don't know, what's the downside here? So let's talk about some challenges and limitations. There's really three main challenges and limitations. First is cost, second scan time, and the third is non-determinism. So for perspective, these results we see on the right, this was about 4,500 lines of Rust. It cost about $4 and took about 11 minutes. Now, 4,500 lines, like that's pretty small, right? That's not a whole lot of code. $4, that's certainly more than what it would cost using traditional static analysis, right? And 11 minutes, I mean, it's not terrible, but it's not really fast either. So one of the questions that we get asked a lot, sort of internally, right, amongst the teams, like, hey, is this a problem? Like, is this going to cause folks to sort of steer away from this technology? And I'm going to argue that if you view these as challenges and limitations, oftentimes that's because you're trying to shoehorn this new technology into the behavior of the traditional static analysis, right? And so I would actually argue that instead of looking at this as traditional static analysis, it's really more akin to a human code review. So to put that in perspective, like I said earlier, I spent years doing code review, and the things that we're finding with Pigeon are as good or better than the stuff that I would find as a human, like really good stuff. So if I were to go and review this application, maybe I'd scope it at a couple days of work, and a bill rate of a couple $100 an hour. So we're looking at a few $1,000s in a few days' time to get these results. Well, now all of a sudden that value proposition sort of shifts, and that $4 in 11 minutes looks pretty good, right? I would also say that it's somewhat similar to a human code review when we look at the non-determinism aspect. So with the non-determinism, what happens is if we scan a code base once, we'll use this code base, for example. I think the first time it gave us like 10 results, right? And then we scan it again, and it gives us 10 results. But the third time we scan it, we get an 11th result, right?
Yep.
Well, where did that come from? Well, it's the non-deterministic nature of the technology that we're using. It came to a slightly different conclusion on that third run and gave us a new result. And then maybe I scanned it a fourth time, and that result disappears, right? Some people would say, well, that's a good thing because, hey, you found on that third scan, you found a result that you wouldn't have otherwise found.
But I think as well, it goes to show, yes, there is still non-deterministic behavior there, but with all the guardrails and the way the platform's been built with the smaller units of work, it's not orders of magnitude more, right?
Exactly.
I mean, it's single items, it's one or two here or there. So when we engage in this conversation, it's quite difficult, right? Because we sell Coverity, right? These customers are we have a pool of customers that are really interested in the deterministic nature of the results that we get, right? They're repeatable. And when we show them this, it's a concern. But then there's other customers that actually go, do you know what? For the value, for the type of findings we can get, that's not really an issue. But there's work in this area and research we're engaged in where, how do we manage that through a traditional workflow of vulnerability management, right? So there's systems that we can deploy, whether it's caching, it's merge keys, it's vector searches, and we get into a confidence rate and a similarity search, right? And some of the oversight that we have tries to tune out some of the non-deterministic nature of the reporting of issues, right?
Yeah, exactly. So there's multiple stages in this system, and essentially, during one of those stages, there's a hallucination.
Yeah.
And so we get some crazy result. Then there's actually an oversight agent that will review that result in the context of the application and say, no, this looks like a false positive or some trash, kick it out, like don't report that. So we get rid of a lot of the non-determinism that way. It's still not completely gone. And again, that goes back to what I said earlier with you've sort of got to reframe the way that you're thinking about this technology and view it more as a human code review than a traditional static analysis solution. No one in here would say, oh, look, I paid 3 different consultants to review my code. One of them found something the others didn't. That's crap. You would say, no, that's like expected, right? They came to different conclusions and found different things. So yeah, that's just part of it. One of the other things that is sort of cool is early on we made the deliberate decision to use off-the-shelf LLMs. So we're not using fine-tuned LLMs or anything that we've custom tweaked. They're all off the shelf. And so what this allows us to do is use our traditionally good, fast, cheap triangle here to plug and play these things based off what we're trying to accomplish. So if we want to have a scan that is really fast and really cheap and more of a find us the low-hanging fruit kind of scenario, then we can plug in an LLM that does that. Or if we have some business critical functionality, we say, look, we really need to hammer this thing hard and find as much as we can. Well, let's put the expensive LLM on this and have it really churn away, and it's going to cost more, but we'll get better results.
Yeah, and of course we're obviously assuming that over time these models will just get better, right? So a lot of the things that we're trying to tune out will be tuned out for us, and then it would just be even more performant. But again, to David's point, why we wanted to not go down the road of fine tuning, because it really sort of puts it in as a pigeonhole, right? And then we can't go anywhere from there. So, throughout all the guardrails, we're experimenting with different models for different tasks, specific tasks based on the context, let's flip. So there's lots going on in there, and we didn't want to deliberately, put ourselves into a position where we couldn't leverage other models.
And so we've actually built this entire framework that allows us to run Pigeon with different models and then evaluate the results against the benchmark. So when the next model drops and it's like, hey, look, it's twice as expensive. Well, let's run it and see if the results are twice as good, right?
Yeah.
The other cool thing about being able to plug and play models is on the cost side of things. So it's October now. If I go to a car lot and say I want to buy a car, I can get a good deal on the 2025 models because the 2026 ones are coming out now, right? And it's the same thing with LLMs. The ones that are, the models that are super expensive right now, as soon as that next latest and greatest drops, then it becomes cheaper. Yeah. So again, really allowing us to sort of fine tune and play with the models we're using to achieve the result we want.
Yeah, and it just goes to show sort of the engineering discipline in the platform, right? Because we don't want to get caught up in the hype of we've just launched a new model and here's the parameters and here's the benchmark results, and we think, oh, we can just throw everything at this one model and it will do everything, right? We want to track smaller specific units of work with the models that make sense, right? Yeah. And make that customizable because this will change, right? Everything changes so fast.
That's a good point, right? We use different models for different things within the system. So we have models that are really good at understanding code and navigating the original source files that we're analyzing. Then we have other models that have really good reasoning ability. And so for those, we put those in the agents that are doing things like the oversight and looking at chaining different attacks together so we can leverage the strengths of those models where it makes sense.
All right, so obviously, what else can we do with this platform? And we were talking about this, it first started with how can AI play in the world of SaaS, right? But really this is what we've been building out as a platform that could go in any direction at this point, right? You're adding bootstrap another agent, put it in there, and use what we've already built, right? Yeah. So obviously, our strengths are in SCA, right? We've got the knowledge behind our Black Duck knowledge base, right? So we can use that for additional context and libraries that we come across, for example. Post-quantum cryptography, right? Some of our colleagues in the room here have been working on that. How do we detect your safe usage of crypto, right? We know around the corner, how can you be in a strong position when this comes around the corner, right? So how can you be in the strongest position?
And one of the things with PQC is you need to understand the context of the application, right? Because depending on what the application does, there's different levels of crypto that you're supposed to be using. And so being able to understand, hey, this is a banking app, or no, this is just some web form, it gives us the ability to more accurately say, no, this is a problem because you're using the wrong level.
Yeah, and then for those of you that attended Vanita, our colleague's session, one of our examples was around manually verifying through exploits, right, and manually driving that, and also validating the fixes. And that's a whole other branch of research that we're conducting. But given the fact that we're using this agentic approach, right, we can then just go and verify that these issues are actually exploitable, right? And we were talking about the example of a command line, right? If this is a total command execution, who cares, right? You're a local user on your system that has access to it, right?
Yep.
So we're looking at how can we combine these techniques that sort of have sprinkling of LLMs in it together to really revolutionize the identification of novel new issues, right? Novel issues that traditionally we couldn't really find. And then finally, there's the sort of summarization piece, right? That's what the LLMs are really good at. We've heard that, through some of the talks we've sat at, they're really good at these things and really bad at this stuff, right? So we're leveraging the good, but we're harnessing the LLM to really train it to a point that we can use it effectively and identify those traditionally challenging areas. So I mentioned the MITRE ATT&CK chain, right? So vulnerability management, you have all these lists of issues. Which of these can actually be used in combination? Or, the malicious code detection, for example, that would really heighten that, right? So everyone is struggling with too many issues. It's what we hear from customers all the time, right? We've got new coverage, we've got new checkers, but hey, I've got so many issues, I can't do anything about them, right? Reachability, prioritization, whatever it may be. So using this summarization, we can then get to a point where we say, hey, look, you've got all these issues, this is your top 5 to go fix, all right? We can really home in on the context of the application, where is it deployed in your environment? One thing in the industry today, we don't really make use of, CVSS, right? Everyone just sees a number, right? It's got the temporal, it's got the environmental. Nobody really augments the environmental metrics to adjust scores of particular vulnerabilities. So we can start harnessing that and start really building a proper prioritization list based on that data, right, and those manipulations.
And so one of the things that we've quickly realized is we're not the only players in this space, right? There's quite a few other folks that are doing similar work. I'll say that based on all of the papers and other research that I've ingested, everyone's taking a little bit of a different approach than what we're doing. But again, a lot of players in this space. With Project Pigeon, we've actually got a patent pending on some of the methodologies and techniques that we're using. But when I see all these other folks doing similar things, to me that's validating. Hey, there is actually something in this technology, and validating what we're seeing in our research and results from using this and developing it.
Yeah. Final slide. Whilst we are really passionate and excited about the LLMs and the work that we've been doing, we're also realists, right? We would never imagine that this sort of solution would replace traditional SaaS. There will always be a need for traditional SaaS. But we're just focused on how can we leverage the power of AI to really address the gaps that traditional SaaS can't, right? And from there, you can see it's also a launching point, right? And I think that's more of a agnostic point around all the companies, right? I mean, you need to build muscle in how to use these technologies, how to deploy them, how to monitor them, how to develop them, and how do we bring our internal teams to safe usage of these technologies and understand them and be creative, right? So there's it's really important that we keep driving this, but we're very clear that this will augment existing processes and never replace it, right?
Yeah, and I mean it goes back to the use case here, playing to the strengths. If I've got 2 million line of code base, I'm probably not going to use this to scan the whole thing. I'll come back a week later with like a $30,000 usage bill. Yeah. But what I could do is say, look, this is the authentication piece, or this is some security sensitive piece that's sort of used throughout here. Let me focus it in on that and see what it uncovers. The same way that I wouldn't pay a human to say, look, you've got to lay eyes on every single line of this 2 million lines of code. I would say, look, we've got this particular library. Come in and review it and find those vulnerabilities, because this is a critical piece of the system that we've built. So similarly with this technology, sort of figuring out how to focus it and use it and play to its strengths is important, right? And that's why these complement each other instead of cannibalize each other. Yeah,
absolutely. And we've seen with the malicious code detection, right? You could say, traditional SaaS would struggle in that space, but this could be leveraged for your build systems, right? Mm-hmm. And looking at that infrastructure, and that could be a really good testing ground for that. So, we're really impressed with it and the technology and what you can do. But I think the key takeaway for us is, you can't simply build benchmarks and tests by just using one model and throwing one prompt at it and saying it's rubbish, right? I mean, that's really unfair. I think you really need to understand your use case and what you're trying to address, and then build a system around it to help it be as best as it can be, right? And really help you.
Well, yeah, because we've had multiple people come to us and say, hey, look, we tried to reproduce what you guys did, and it can't be done. Like, there's no way you are doing this with just LLMs and agents and doing cross-file data flow on the actual source code text without having some intermediate representation. And the reality is we are.
Yeah, so, all right, that's us. Thank you very much, guys. Really appreciate it.